How can I use triangle similarity rules to determine two triangles, to determine if two triangles are similar? We're going to cover three types of similarity today. And then you're going to be determining if triangles are congruent, and if they are, you're going to be writing congruence or similarity statements. So first of all, you've got angle-angle similarity. Angle-angle similarity states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. In the example that's given on the bottom of page 478, you've got a smaller triangle JKL, and you're given two angle measures. Angle L is 57 degrees. Angle J is 48 degrees. And then you're given a little bigger triangle to the right of it, MPQ. And you're given angle M is 57 and angle P is 75. And you're asked to determine whether the triangles are similar, and if so, write a similarity statement and explain your reasoning. By first glance, you'd probably say they're not similar, but you're missing an angle measure in each triangle, aren't you? So in the triangle on the left, take the two given angles and subtract them from 180. And the missing angle is 75 degrees. And now you've got two angles in one triangle congruent to two angles in another triangle. So the triangles are similar, aren't they? If the triangles are similar, you're asked to write a similarity statement. When you're writing your similarity statement, the description of the first shape, the order of the letters doesn't matter. So you can call the triangle on the left JLK. So triangle JLK is similar to triangle. Now's where it gets important. If you called it triangle JLK, similar to triangle, since you started with the J, and the J was the 48-degree angle, well, you know that if these two angles are 57 and 75, and these two are 57 and 75, then this third one's got to be 48, doesn't it? So if you started with the 48-degree angle on the triangle on the left, then you got to start with the 48-degree triangle on the right. So first letter's got to be Q. And then you went JLK, so you went 48, then you went to the 57-degree angle second, so you got to go to the 57-degree angle second. So that's going to be QMP. Okay, so that's your similarity statement. And explain your reasoning. You're going to explain your reasoning. You're going to write by angle, angle. And that's short for angle, angle similarity, but you don't have to write all that out. Okay, so by angle, angle similarity is your reasoning. So triangle JLK is similar to triangle QMP. By angle, angle, you can maybe abbreviate it. Angle, angle similarity. There's another example just to the right of that. Example B. Kind of looks like his bow tie. And you're told that Rx up here R to X is parallel to T to W. And this vertex is S here in the middle. Alright, and again you're asked if the triangles are similar. And again, by first glance, they don't give you any angle measures. They don't write in any angle measures. But you got to think about some of the rules that we've covered this year. This vertex S right in the middle of these two triangles creates two vertical angles, doesn't it? So this angle is congruent to this angle. Now the fact that Rx is parallel to TW creates some transversals. This angle right here, angle X, is going to be congruent to angle T. Because you've got two parallel lines and you got a transversal that intersects them. You've got the same thing with RW. This angle would be congruent to this angle. So now it changes the picture a little bit. You've got two angles in one triangle congruent to two angles in another triangle. So the triangles are similar. So your similarity statement would be triangle. Again, call the one on the left whatever you want. SXR is similar to triangle. What does the order of the triangle on the right have to be now? It's got to start with S, doesn't it? What's got to be the second letter? T, good. STW. Okay, so there's your similarity statement. By, your reasoning is by angle, angle, similarity. Okay? Two angles in one are congruent to two angles in another. Therefore, the triangles are similar. Look at the top of page 479. Side, side, side similarity. Side, side, side similarity says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So let's look at a couple of triangles. We'll call the top triangle PQR. And the bottom triangle RTS. And you're given some sides, 5, 6, and 8. $12.5, 20, and 15. All right, so using side, side, side similarity, if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So let's write some scale factors, compare their scale factors, okay? If you don't know which sides correspond, then you start off with the length of the sides. Take the shortest side in the top triangle, okay? And that's 5, isn't it? And put the 5 over the shortest side in the bottom triangle, which is 12.5. Those two sides correspond to each other. They're both the shortest side in each triangle. And then take the medium length side. In the top triangle would be a 6, and in the bottom triangle would be a 15. And then take your longest sides in each triangle, and you got an 8 and a 20, so 8 over 20. So you're basically writing 3 scale factors, and you're just going to compare them. So in your calculator, take 5 and divide it by 12.5. And you got 0.4, good. Then take 6 and divide it by 15. You got 0.4 again. And one more time. 8 divided by 20. 0.4. So are the triangles similar?
Yes.
Very good, they're similar. So the similarity statement. Call the top triangle R triangle, what do you want to call it? RPQ. Okay. Similar to triangle. Now if you started with R, and R is in both triangles, isn't it? In your second description, the first letter has to be R. Now, you went RP. Okay, so you used the 8. You used the side that was 8 units long. Well, this shows you what corresponds to the 8, doesn't it? So which side do you use, which vertex do you use next? S, very good. So RST. Okay, and your explanation is by side, side, side similarity. If the 3 scale factors are equal, then the triangles are similar. Write your similarity statement, explain your reasoning. Any questions about side, side, side? Alright, and finally today you've got side angle side similarity. Side angle side similarity. If two sides of one triangle are proportional, to two sides of another triangle. And The included angles are congruent. Then the triangles are similar. Side, angle, side, similarity. Yeah. All right, so another bow tie picture. Triangle on the left, TZW. And it's got two side lengths of 10 and 11. Triangle on the right is WXY. And its two side lengths are 22 and 10. Are the triangles similar? If so, write a similarity statement and explain your reasoning. Okay, so again, you have two triangles that are sharing a vertex, and if they're sharing a vertex, this creates vertical angles, doesn't it? So this angle is going to be congruent to this angle. Now, proportional sides. Or, if two sides of one triangle are proportional to two sides of another triangle. You can take the 10 and put it over the 20. This is the smaller of the two sides. Put it over the... Oh, that's supposed to be a 20. Sorry. Put it over the smaller of the two sides. All right, so you got 10 over 20. Does that equal 11 over 22? 10 over 20 is a half, isn't it? Or 0.5. And 11 divided by 22. 0.5. So the sides are proportional, aren't they? The included angles. You got the side that's 10 and the side that's 11. The angle in between it is called the included angle. You got the side that's 20 and the side that's 22. The angle that touches those is the included angle. So the included angles are congruent. So you can write your similarity statement. Again, you can call the triangle on the left whatever you want. Triangle WTZ is similar to triangle. If W went first, W's got to go first again. W. Alright, so we went WT. So we did the short side of the two. So we got to go W, Y, X. Okay? Triangle WTZ is similar to triangle WYX, and that's by side, side, side similarity. No, side, I'm sorry, side, angle, side similarity. Does anybody have any questions?